If you want to be a better hydraulic modeler, you're in the right place. Today's video is part 2 in a series on 2D hydraulic modeling with SMS. In today's video, I'll show you how to generate a mesh. The first thing you'll need to do when setting up a mesh for your 2D model is to create a scatter set like the one I have here. If you're not familiar with how I got to that screen, you could check out our previous video. It was titled SMS Basics Part 1, Terrain Setup and Merging Scatter Sets. I encourage you to check that out if you don't know how I got to this screen. But to set up a mesh, we're going to break this up into 7 steps. The first thing you'll need to do is set a model extent. Some people refer to this as a model domain. It's basically just defining how big your model is going to be. Step 2 would be delineating key features such as your river channel banks, roadway embankments, and whenever you do this, you're going to want to basically capture all of the significant elevation changes in your scatter set. 3, you're going to redistribute your vertices just to make sure you have an even spacing and an appropriate spacing of the vertices along all of the arcs that we're going to create. After that, step 4, you'll generate polygons. Step 5, we'll assign mesh types. 6, we'll map the mesh to this terrain that we have created. And then step 7, we'll just do an overall review and troubleshoot our mesh. So the first thing we're going to do is set the model extents. To do this, I'm going to need a little more information than what I have on the screen. I like to start with an aerial image. You can get that by going to File, Add Online Maps, click on the world imagery, and then click on OK. It'll take a few seconds for this to load, but when it does, you'll have an aerial image that maps to your window size. So if I zoom out, it'll update. And then I can zoom back into my model and it'll refresh itself. Next thing I'm going to do is adjust the transparency on my scatter set so that I will be able to see the lines that I'm going to draw here in a moment. You can go to your Contours tab and change the transparency. I like to start with 50%, maybe do a little bit higher than that, but this is a good starting point. Next thing I want to do is actually I don't like all those contours on, so I'm going to turn those off. We'll just do a color fill. Next thing I'm going to do is bring in the FEMA flood map. You can download these from FEMA's website. A couple different ways you can do it. You can download the image, which is what I have here, and if you're not sure how to get to these images or these FEMA files, just let me know in the comments and I'll step you through it there. So what this shows, if I turn the scatter set off, this is just a FEMA flood map. It gives you a basic idea of how wide the floodplain is. A lot of these FEMA maps are not very good, so I encourage you to just use that as a starting point and then lean more on your LIDAR, these ridge lines, high ground in your LIDAR. It's kind of hard for me to see what's going on in this FEMA map with the LIDAR turned on. So I actually, rather than leaning on that, I like to download the shape files of the FEMA map. All the files that you'll get look like this. So when you'll download it as a package, and I like to find that flood hazard area file is just a shape file. And then you can drag that in, and it's just this floodplain outline right there. So I can actually work off that, and I'm going to remove this image and just use the outline of the floodplain. So the first thing you're going to want to do is create a new coverage. This is going to be a mesh generator coverage, and I'm just going to call this example mesh generator, and then we're going to start drawing lines. So you got to highlight that coverage to make it active, select the create feature arc tool, and then you need to decide where the upstream end of your model is going to be. So for me on this project, my subject crossing is right here. There's a bridge along that road, and I want my upstream end of my model to be far enough away so that the bridge isn't impacting the hydraulics at the upstream end of my model, and the downstream end for that matter. But so to decide how far away you need to be from your bridge, or how far upstream from your bridge this model should extend, a general rule of thumb is 5 floodplain widths. That's basic, but it gives you an idea. Another thing you want to look for is narrow areas in a floodplain. The model just runs smoother whenever you don't have to model wide areas in a floodplain at the inlet or at the exit boundary. So fortunately, I've got a narrow section up here that's far enough upstream that I don't expect this bridge to be impacting the hydraulics up here. So I'm going to use this as my inlet area. And then for my exit, again, my bridge is here. I need to be far enough downstream so that the hydraulics through the bridge, so that the flow through the bridge has enough time to fully expand and balance itself out. So it should expand at roughly a 2-to-1 ratio. And by the time I get down here, it should be pretty smooth. So I'm going to use maybe like right here, something like this as my exit. From here, actually, I'm thinking maybe this should be a little bit further, and I'm gonna widen that. Now that we've defined how long our model will be, we're going to define how wide it's going to be. So to do that, we're going to create another feature arc connecting the inlet boundary to the exit. You're just connecting one node to the other. And I want to kind of generally follow this FEMA flood boundary, but I don't want to be too close to it because, like I said, the FEMA flood zones are not perfect. And we want our model to be a little bit wider than the actual floodplain is, because we don't want to run our model and then have our flood boundary bumping up against the edge of our mesh. If we do that, then the model is going to treat it like a vertical wall, and it won't give you an accurate flow depth distribution. So we want to leave a little space between our model extent and what the actual floodplain is. So we're going to come off of that FEMA flood zone a little bit, and we're going to connect these nodes. That's our left descending bank. Now we'll do our right descending bank. Usually like to work upstream to downstream just because I'm used to doing things in Hecras. I don't know that it matters in SMS, but it's just kind of a habit. And that's our mesh domain. Step 2 is to delineate key features such as your channel banks, roadway embankments, building footprints, or anywhere else where you expect there to be a sudden change in elevation. I like to begin with my channel, so you can just click on an arc that you previously created to begin a new line, and you want to trace this all the way through the length of your model. You can double click if you want to stop a line and start a new one. Again, for your channel, you want to make sure that you carry this all the way through your model. For a roadway, they're kind of hard to see sometimes, so I like to turn my imagery back on. So now I can see my road, and I can trace each side of the pavement. I would normally carry this all the way to the other side of the model, but for time, I'm just trying to show you some different things. So that would be the pavement. You also want to I know that there's a roadway embankment here, so there's a change in elevation. That's a place where I would want to have an arc that follows along the roadway. Buildings, all of these buildings I'll have delineated. This railroad track, so you want to have your railroad. And once you get all of these features delineated, you can still make changes to the vertex locations. So if you click on this vertex selector tool, you can click on any vertice and move it around. So that's a helpful tool to keep in mind. You can also add vertices with this button. You know, you can drop another one in there. I don't like this, how far this is spaced out, so you can put more in here. We'll cover that more in step 3. But for now, just keep in mind that this is a tedious process. It does take time. So take your time and try to delineate things as accurately as you can. Since it's going to take a while, I'm going to fast forward to the end and then just show you what I ended up with. So this is not the end, but I wanted to kind of show you just how some of these features could tie together as you're building them. And actually, to do this, I'm actually going to just break my model in half. Bear with me just a moment. We'll do all this. So this will divide my model, and if I could have clicked on the right spot, and then I'm going to select, you can hit your shift key and it'll let you, actually it's the control key, it'll let you draw a line like that, and then release, press delete, and I'm gonna pretend like this is my model. Okay, so this was the roadway embankment that I was telling you about. When you connect to the channel, you're gonna end up with these nodes in the middle, and that's going to mess up your vertex distribution. So what you can do is select those with this tool, this node selector tool, draw a box around it, right click, hit the nodes to vertices, and it's going to switch those to vertices. So once you get all of your, I said I didn't finish my road, but once you get all of your key features delineated, and then you can move into step 3, which is to redistribute your vertices. So your roadway embankments and your railroad embankments, you can select this, right click, hit redistribute vertices, and then you're going to assign a spacing for those embankments. You can do a number of segments along that arc that I had selected and divide it into segments. Let's say I wanted it to be 5 segments. So now this is 5 segments wide, but I like to redistribute them with an average spacing, or at least to begin with, let's say 100 feet, and then we could do that on both sides. Or what you could do is you can select this line and see that it has 16 segments, and then you could redistribute this one by segments so that you know that it has the same number of segments on each side. And that becomes important when you're generating polygons, but I'll show you that in a minute. For your domain extent, I usually just assign this to something like 250 feet to start with. That may even be too small, but we'll call it 250. You could do that on either side. Same thing at your upstream extents. Actually, just to save a little time, I'm just gonna drop some in there manually. Boom, boom, boom. You can do the same thing down here. Try so that when this triangulates, is when it creates a mesh, it's going to connect each one of these vertices to its nearest vertices. So if I were to generate a mesh of this polygon, this node would end up with a line going there, 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 and we call that like a wagon wheel feature. Try to avoid that, and you can avoid it by just adding some vertices there. So that'll make like a nice smooth triangle. For your railroad and your roadway embankments, really any long, skinny rectangle, it's important for the end of those shapes to be defined with more than one element. I like to have at least 3 here, so we'll have 3 elements on that end, 3 elements on this end. This will make sense after I create the mesh. I'll show you that when I get there. That's going to produce a nice smooth mesh. This channel, however, is currently trash, and let me show you why. So if we go to step 4, which is to generate polygons, and I go feature, objects, build polygons, and then this tool will become an option, so I can select this polygon. If I leave it as paving, it will produce several triangles. For the long skinny elements, you don't want that, you want it to be a patch. So then if I preview it, see that's nice and smooth. That's what we want it to look like. Now if I select the channel, you see all these blue dots, those are nodes where there should be vertices, but if I preview that, it's an absolute mess. And if I try to patch it, it won't patch because of those internal nodes. So to avoid that, you can take your node selector tool and you can actually select all of them, right click and convert it to vertices, and it will only convert the ones that aren't attached to another arc. But still, if I regenerate my polygons and select it, it will do a pave, but it will not do a patch. So that means we need to come in here and break this element up some. So we can put one here, and then we can put one there. So we've got multiple elements. See how this one's got 2 on that side. We want to get 2 over here. And my channel needs to be more than 1 element wide. So let's make this one 4. Let's go 4 segments. Make sure you do it on every end. 4. I'm going to do the same thing. Did I not do that? You can actually select it, and if you hit shift, you can select multiple elements and it'll redistribute all of them at the same time. This is still not very good because, and then if I preview it, you double click it to preview it. Let's look at a patch. It still doesn't look too good. It's got this sharp angle here. So we can eliminate that by adding an element right there. But make sure that you redistribute it. Select it, right click, redistribute, make that 4. And then another thing that you want to do is to make sure that each side of the channel has the same number of elements. So like this one has 3 and this one has 4. I'm looking at the bottom of the screen to see. So that has 4, that one has 3. I want to select both of them, redistribute those. Let's make both of them 5 segments. And then this, hit shift and select the other one, right click, redistribute. Let's make that one also 5 segments. So now whenever I select this polygon, I gotta build polygons again. And then when I select this polygon, it's already set to patch. And as I preview, see how much smoother that looks? Same thing up here, nice and smooth. And then down here, you see how my vertices, they aren't right across from each other. That's why redistributing vertices smooths all of that out, but you gotta have the right tool selected to do that. So you select the arc, click on one, then hit shift and click on the other, or you can press the control key and drag your mouse across them both. Just select them, right click, redistribute vertices, 21 segments, and it should space it out more evenly. And then we can build polygons again, select this polygon, change it to a patch and preview it. It did not preview because I have a node right there. So if that ever happens, you can either go back in your mesh generator and fix it, or you can click on that blue node and then change this to a merge, and now you can preview it as a pave, or you can go to the patch and preview. And if you want to zoom in to see how it looks, you can do that here as well. That looks like trash. So to fix it, I'm gonna actually just go ahead and change this to a vertice, and then anytime you have something that looks bad like that, just break your channel up. Hit escape if you make a bad selection, and it's basically like an undo button. I wish SMS had an undo button, it does not. But from there you can select each one of these breakpoints that you just made, right click, redistribute that. Remember, I had 4 segments wide for this channel. Now when I build polygons and select one of them, actually before I do that, I'm going to go ahead and redistribute these It's going to space those evenly. Same thing here. I'm just holding down my shift key. I click here and then I hold shift to click on that one, right click, redistribute. Click one side, hit shift, click the other side, right click, redistribute. So now everything should be nice and smooth when I create these polygons. I can click on one, it's set to patch, preview it, looks good. Same thing here, that looks good. So now I'll fast forward to the end and we'll go back and look at what I have. After you delineate all your key features, you should have something that looks a little bit like this. If you haven't generated polygons, now would be a good time to do that. And you can go to Feature Objects, Build Polygons, and it looks no different. But if you go to your display settings, under your Map tab, you'll see a box here that gives you the option to fill all your polygon shapes. So select that and you'll see all your polygons. They're all the same color right now because none of these have been assigned. But if I use my Select Feature Polygon tool, I can click on any one of these polygons and it'll select it. And if I double click on one, it'll open this window and tell me what type of polygon I have selected. So our next step after we generate polygons is going to be to assign mesh types. So anytime you have a polygon that represents a field or an urban area, something that doesn't produce a rectangular shape, then you can make those a patch. And if you want to, well, I'm sorry, not a patch, pave. And you can preview it by hitting the preview mesh button, and that'll give you an idea of what the mesh would look like after we build it. So to make this a little faster, we can use our shift key again to select multiple polygons. So I'm holding my shift key and I'm going to select every shape that's not a square or a rectangle, basically anything other than long skinny elements. I'm going to try to select, and then I can right click and select polygon attributes, check this mesh type feature and allow that to be paving. And then when you click out in space to deselect everything, you can see that all of those have been assigned the paving type. So now for things like my channel and my railroads, I'm going to multi-select all of those now. If you double click on your last selection, it will bring this box up and you can check that to assign everything that you have selected, whatever mesh type you want that to be assigned. All that looks good. Now for the buildings, I need to turn my imagery on. I guess it just hasn't loaded yet. But the buildings, I actually want those to be unassigned, so, or actually it should be a none. So whenever you change the mesh type to none, the water will not go through that area, it will go around it. So typically for buildings and bridge piers, any type of obstruction, we can just assign that as a none, and it will not allow the water to penetrate the polygons. So we're going to select all of our buildings now and assign all of those to none. Okay, and so now I just need to look and see what I've missed. I'm going to turn this imagery off, and then I'm going to go to my transparency and just turn this off, the transparency, so that this will show up a little bit better. I think everything looks okay, just, you know, for demonstration purposes. This should execute well. There's one that I missed. Okay, so now that we have generated polygons and assigned our mesh types, now we need to map this mesh to a terrain. So to do that, we can have this feature polygon, select feature polygon tool. We can right click out in space and select all, and then we can right click in here and go to Polygon Attributes and click on the elevation type. We want it to be a scatter set, and then we want to go to your other options. If you had a raster in here, you can map to that as well, but we want to use a scatter set. Go to Scatter Options and then click on the elevation, the word elevation there, and then click OK. Click OK again, and what that did is it assigned this mesh generator coverage to this terrain, because like right now this mesh generator, if I rotate it, you'll see that it's just a flat surface. There are no elevation values assigned to it. So when I connect these polygons to the terrain, then whenever I generate a mesh, these polygons will be laid on top of the terrain in order to generate that mesh. So now all we have to do to create a mesh is to right click on our mesh generator coverage, hover over convert, and select this map to 2D mesh button, and then wait, and it'll generate our mesh. From here we'll give it a mesh name. This was an example, and there we have it. I can turn off the mesh generator coverage, and what I'm left viewing is the mesh itself. We can select our little rotate tool to rotate this and look at it, zoom it in out with our wheel, and you can see that there are now elevation values assigned to our mesh generator coverage. So this is the mesh that we would use to run our model after we review everything. So our final step, step 7, would be to review our mesh. Make sure everything looks smooth, make sure that the mesh represents the terrain the way that we want it to. And one of the key things you want to look at is crossing areas like this where my channel is going through the roadway embankment. But as you can see, some of the roadway elevations were attached to these mesh elements in the channel. So a quick fix on that, you want to make sure that you check your survey data and do this appropriately, however you see fit, using your own judgment. But just for demonstration, I can select this node, and this Z value gives us an elevation. So we're at 406.3, and then this other node in the channel was a 404.7. So these nodes, between those two, you could reason that they should be around 405 feet. So I'm just going to select, well, with the shift button, select multiple nodes here, and we can assign those to, if you double click on that value, you can change those to 405 and then press tab, and maybe we want to bring these two down to something like 406. Obviously this is a very rough estimate, so just depending on the detail that you need in your model, you could assign these values to whatever you think they need to be. Another thing you want to look for using your rotate tool is you want to look for artificial dams in the channel. So like down here, you can see that the mesh, rather than picking up the channel values, it just took this top bank and used those elevations across this element in the channel, creating a false dam. So if we zoom in on that area, we can do something similar there. Select these nodes. I'm at 402.2. Right here we're at 402.4. Here we're at 403.8, which is starting to kind of go up to those false values, I think. This is around 400. So if I say, so what was this one? 402.2, and this one's around 400. So if I want to select these and just place those at 401, for example, it would eliminate that dam and allow water to flow through here. This one was kind of the thawag of the channel, so we're going to bring those down a little bit more. We'll call this 400.5. Fortunately, this is far enough away from my study area that it shouldn't have an impact on my study. But I'll be sure to go in and refine this and try to make sure that my mesh simulates the ground as it is today. That concludes today's tutorial on how to generate a mesh in SMS for 2D hydraulic modeling. Again, please use your own judgment whenever you're building these models. What I've showed you today is just how I tend to do it. For more guidance, look up the FHWA website, find some information there from FHWA. They have a YouTube channel with some good tutorials. Aquaveo has some good tutorials on their YouTube channel as well as their website. So gather everyone's opinion and form your own, and good luck in your modeling practices. Thanks.